Hello, this video is going to cover the CyBot Emulator portion of our QEMU development for this semester. So in this video we're going to cover the CyBot Emulator structure itself and then the three new devices that we created for the CyBot. These include the servo, a Wi-Fi device, and a field device. So the general structure of the CyBot emulator is it is built off of the regular TIBA emulator. It just adds the new devices that will be eventually used for a lab environment, and gives the student a way to communicate with the actual emulator itself. As you can see on the diagram here, it is just connected using the GPIO pins we created in the TM4C device. So first, the servo device. It is basically a PWM signal reader. Right now, all it does is it translates the PWM signal that it receives through GPIO in QGPIO in 0 into a duty cycle percentage. And then this is what it sends to the field device. And well, actually, it calculates the degree based on that duty cycle percentage. So 0% would be 0 degrees, and 100% would be 180 degrees. But that angle is what it sends then to the field device for, handling later. This is configurable with a variable pulse width. The default is what the servo is in the actual class, which is 20 milliseconds. So the next device that we're going to talk about is the Wi-Fi device, which creates a server socket to establish communication with the students themselves. It is basically just another UART device. We have copied most of the UART code directly, with just some more limited functionality and fewer configuration. And because of emulation limitations, the baud rate is not hardware accurate with the CyBot. We had to slow it down a lot, so it is set to 500 milliseconds, I think is what that translates to approximately. But it's a lot slower, but it's the best we could get it to work reliably sending data. It creates the port, the default port is 10,000. We were going to use 288, but then we realized ports under 1024 need to be created with pseudo privileges, which we didn't want to have for the emulator. So the next device is the field device. It is a kind of stand-in at the moment for some sort of way of emulating a lab environment with all of the different objects on the field and where the CyBot is. Right now, it just establishes a server for use with a special client that the instructor will eventually have. We have not created this client yet, but we have created the packet system. The idea is that the client will give the instructor a view of the emulated environment, like where the CyBot is, where all the objects are, and then any status and debug information that they might want. It uses a custom packet system, which we will go over in a little bit, and then its default port is 10,001. So right now we have 3 packets. There's the exit packet, and then 2 packets relating to the servo information. Packets are built up of 2 different fields. There's the ID field, and then any associated data field, which we don't have this table. Right now, the only packet that actually has data is the servo response, which will send this ID, and then alongside it, it will send the actual direction that it is facing in degrees from 0 to 180. The most significant bit of the ID we have currently representing, saying, hey, this is a response or a request, So these first two are requests. They have a 0 in that first bit, whereas this one is a response, so it uses a 1 that bit. Under the hood, the socket handling is done with multi-threads, multiple threads. We have created a socket handler library that really simplifies it for use with the rest of the emulator. This is the Wi-Fi device code. That's the Wi-Fi.c. So the main thread will just have to worry about Wi-Fi underscore receive and Wi-Fi underscore send, which will communicate with the send and receive FIFOs. This simplifies communication a lot, and it handles all of the these two methods handle all of the mutex and multi-threading safety stuff. But the idea is the main thread will first create their server, giving it a port and then a callback for when a connection is made, so that the main thread can do something if you want. And then when the server thread is created, it will start listening on the port, and then once it gets a connection, it will create two new threads, one for sending data and one for the receiving data. The receive thread will do its own FIFO operation, like both of them will do their own FIFO operations with the send and receive FIFOs. Also thread safe stuff. But the main interface you need to worry about is the create server to start up the threads, and then the Wi-Fi send and receive to collect and send data between the sockets. So that is all the information we have for the CyBot right now. It's not very finished, but we put a bunch of work in there. This is the document going over all of the emulator stuff. Right now, this video went over the CyBot implementation, and previous videos went over the actual TiVo board itself and the QEMU development concepts and installation. Thanks for watching.